Hello and welcome to the channel. In this video, I'm going to show you a very interesting little simple and lightweight text classifier with LLM embeddings. We will be looking and installing this Fastc tool, which is focused on limited memory CPU execution because it uses efficient distilled models such as Tiny Roberta on Hugging Face, as you can see here, and I will get to this model in a bit. But let's first see what this fast C does. As I said, it is mainly used for text classification. For example, you give it some sentence or some um, list of sentences, and then it classifies into various labels, and I will describe it in bit more detail. So one of the key feature is that it Fastc enables you to run these sort of text classifier models on even CPU. Also, it enables you to bypass the need for fine tuning by utilizing LLM embeddings to efficiently categorize text using either cosine similarity with class centroids or logits regression. Also, you can even run hundreds of classifiers concurrently with minimal overhead by sharing the same model for embedding generation. One of the use cases I have seen this model being used a lot by using Fastc is that where you have tons and tons of data and you simply want to classify the sentiment of that text, whether it is, for example, there are insurances uh, chats of customers. You want to check the sentiment of that chat, whether it is positive or negative. So you just feed that tons and tons of data to this text classifier with the help of Fastc, and then it gives you the sentiment after classifying that text in a very short time using very little resources. So that is the main use case of this Fastc. Now, coming to this Roberta model, Tiny Roberta model, it is a text classifier model that's a smaller, more efficient, distilled version of the larger Roberta language model, specifically designed for question answering tasks. It is a distilled model trained on the Pile dataset using 4 Tesla V100 GPUs with hyperparameters like batch size 96, been fine-tuned using 4 epochs, and learning rate is also very small. As a text classifier, it takes text input and assigns it to one or more categories or labels and is particularly designed for extractive question answering, identifying answers to questions within a given text passage. So that is its sort of nature of the model. Now let's get this thing installed and then we will see it in action as how it works. Before I show you the installation, let me give a huge shout out to Massed Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video description, and I'm also going to give you a coupon code of 50% discount on a range of GPUs. Okay, so this is a VM I'm using, and this is the NVIDIA card, 48 GB VRAM, NVIDIA RTX A6000, courtesy Massed Compute. For this model, of course, you don't need that much GPU. In fact, you don't even need a GPU. You can run all of this stuff on CPU. Let me create a Conda environment, which is going to keep everything separate and simple. And then we will be creating a Jupyter notebook in it to keep everything separate. So you can see that this environment is created and we have already stepped into it. Let's install Fastc with the pip. As you can see, it's very simple installation, very lightweight. And now let's install our Jupyter notebook and we will launch it in the browser so that we could play around with this Fastc after downloading the model. So let's wait for it to finish. Should not take too long now. Okay, so Jupyter notebook is launched. As a first step, let me show you how easy it is to fine tune a base model on your own text for classification by using Fastc. So first we are importing Fastc, then give it some data. In this data, we are just giving it as a tuple where we have this sentence and then its semantics, whether it is positive or negative. So if you have your own data, you can fine tune this base model, which is Deberta base, with using Fastc. And then once that's done, we load the data set and then we train the data model by using this data set. So let me run it, and you can see that it has started downloading the model, which is not big, and then it is generating the embeddings. Shouldn't take too long because our data set was very small. It has already fine-tuned it. How cool is that? Now after training, you can simply save it locally by running this command model.save. It has saved it locally. If you want to push it to Hugging Face, let me quickly show you the command. It is very simple command. Push to hub, and then you can just give it your directory. For example, this is a creators repo on Hugging Face. If I wanted to do my own, I will just say my repo, and then whatever name I wanted to give, I will give it here, and then you can give it tag and all that stuff. But I'm not going to do it now. Later on, if you want to use it, simply run this command model is equal to fastc this, and it is going to load your model. So it's, I already have it, but I just loaded it again, as you can see. Or if you want to get it from Hugging Face, if you upload it there, you will simply run this command, your repo name and then your model name, but we are not doing it. Now if you want to predict the class, let me or the classify, I mean, let me show you how to do the single one. For example, we have given it two sentences: I am feeling well, I am in pain. And then let's predict with the help of model the only first sentence, and then see what model says here. Let's run it, and there you go, we got the error. So what the error is here, let's check. Okay, so this is interesting actually. So primarily, this error method suggests that the pooling strategy used in the get embedding method is not supported, and it will be different from different models. And the pooling parameter primarily specifies how to combine the embedding from individual words or subwords into a single embedding for the input text. And embedding is simply a numerical representation. So in order to fix that error, you would need to check the pooling parameter on its model card on Hugging Face to see what sort of pooling it supports. It could be mean, as you can see that I have just fixed it by using this mean, or it could be max, min, or sum. So let me run it with mean here. And there you go. So the model has predicted the class here, and in this case, the model is predicting that the input sequence I am feeling well belongs to the first class, which is indexed by 0, so which is positive here. So amazing stuff. You can already see that how easy it is to do the prediction and classification. And similarly, when you would say sentence 1, the second item, it has selected the or classified it in 1, the negative class. So all in all, very easy to fine tune it, very easy to do the inference and classification it with it. And as I said earlier, if you're looking to classify a huge or humongous amount of data with faster, smaller, lighter models, Fastc is a very good option. So that's it guys. I will drop the link to it in video's description. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.